Okay, sorry, I'm not doing too well today. I almost didn't come. Um, guys, get your quizzes back. I mean, I've got, you probably know what the answers are. You got them all in your notebooks, right? Okay. So if you did have something wrong, I'm sure by now you know what it was, what it should have been. Is that true? Now, it's at this point in this trig course that I get to share with you a couple trig jokes. Okay. Yeah, I guess let's look at this one first. It's actually a quote. Jason Kidd, when he was drafted by the Dallas Mavericks, said, "We're going to turn this team on 360 degrees around." Okay. Of course, what happens when you rotate 360 degrees? You don't change anything, yeah. So I'm sure he meant, what, 180? Because at that time, Dallas was not doing very well. Let's see, I'll get to it right now. Okay, now this one I think you're going to like, I hope. And you should really get it now. Okay, now, obviously this chart is not correct, right? There better not be anybody in here who thinks those UNDs are in the right place. Okay, they're not. And so, here's the joke. The question is, what's wrong with the student who filled out this trig table? Answer? He's got his undies in a bundle. Sorry. You can only appreciate that if you know what these lines are. So, hey, some of you smile. Thank you. And there, but I see when I couldn't show you that at the beginning of the course, you'd be like, what is this UND stuff? Okay. Well, trig 7. And you got your, well, just quick review. Yesterday, what did we do? We learned the reciprocal functions. And so that meant that we know that the cosecant is just a reciprocal of the sine. And so every time I'm asking you for the cosecant of 30 degrees, really all I'm asking you for is 1 over the sine of 30 degrees, right? And then we had to learn a couple, I guess you had to be cautious in a couple of places. There's a few numbers you cannot reciprocate, like 0. It's impossible to take the reciprocal. And so we realized that we just have to write an undefined there, or put down an unde. Okay. And then what happens when you have a UND? Well, you can't take a reciprocal of nothing, but it turns out it is the opposite one is always going to be 0. And so, in effect, didn't we not double the chart yesterday in class? Does anybody have any questions about that? Yeah. Well, yeah, I'll get this. I haven't actually showed yet, so no, that's quite all right. I'm going to get to that in just a moment. Well, no, this is the new stuff. Okay, for the new stuff then. All of you remember that the sine in our unit circle wasn't the SINE always the vertical leg? This guy? And wasn't the cosine always this guy, the horizontal leg? And isn't the hypotenuse always 1? So do you understand, first of all, my labeling there? And then I think I did show this to you last time in a little different slide. Then shouldn't I be able to use the Pythagorean theorem? Yes, if it's a right triangle, absolutely. And so do you see what I did? I took the one leg squared plus the other leg squared equals the hypotenuse squared. And I think I showed this to you last time. The end result is what we call a Pythagorean identity. Now, what do we mean by an identity? No matter what angle is plugged in for theta, this will always work. So if you plug in 20 degrees and did the sine of 20 and then squared it, and then did the cosine of 20 and then squared it, and add those two squares up, I guarantee you the answer will be 1 every time. So that's pretty cool when no matter what angle you pick, it works. When that happens, those are elevated as very important, and we call them identities. And in fact, it's one of the 3 Pythagorean ones. Why? Because it comes from the Pythagorean theorem. Now, yesterday I just showed you these other 2, but I didn't show you these diagrams. You should have this one on your notes from last time. Does that look familiar? I think I wrote it in red in a box. And this one should look familiar over here too. Again, I had it in a box. Okay. What I didn't show you last time was that actually these things can be thought of as parts of a right triangle. And so do you see how we have kind of an upside down right triangle for this? I know I don't expect you to remember this, but actually you can identify the sides of this right triangle with 2 of those reciprocal functions. This horizontal guy here is called the cotangent. This hypotenuse is actually the measure of the cosecant. You notice it goes outside the circle, otherwise it would always be 1. And sure enough, if you take one leg and square it, plus the other leg squared, you really get the hypotenuse squared. Now, had we had a little more time, I'd have developed that more. But so actually, did really come from a right triangle, and so this is one of the Pythagorean identities. Pythagorean theorem. Likewise, over here, this is so tiny you might not be able to see it. This guy, this red guy over here, we call the tangent. This blue guy, in this case, is called the secant. And here, of course, that's a 1. And if you take one leg squared, tangent, square it, add it to the other leg squared, you get the hypotenuse squared. And so I just wanted to show you that those really do come from right triangles. I wish I could spend more time on those with you. Another one. So anyway, this is really not new, but I'm showing you a little more that went behind what I showed you yesterday. And those we went through last time, right? Yeah. Now, what I wanted to show here is that these, I just don't know how much time and can I stand it. I have this, I guess I could call it acute indigestion. I will stay away from the front row so I don't spew any streams, okay? But it's not good, so I don't know if I'm going to make it here. I think I'm just going to... So anyway, what I wanted... let me try to go through one of these. I wanted to show you that you can prove these guys. And I don't mean in geometry proof. I mean in an algebraic type proof. So for example, I took the second one there. Tangent squared theta plus 1 equals secant squared theta. Now, in a right triangle, let me draw up here and show you where I got those things from. In a right triangle, and if this is theta down here, whoops, if this is theta, then isn't this guy down here, because it's the horizontal coordinate, kind of the x coordinate, and isn't this thing over here because it's vertical, the y coordinate? And this thing over here is called the radius of the circle. I don't have the circle drawn, but it's the, the hypotenuse is the radius of the circle. using those letters, look at where I got this stuff from. What's the tangent squared? Well, what's the tangent of theta? Opposite over adjacent, y over x. You see why I squared it? Because it was in the formula. Plus 1 equals the secant. Now, what's the secant, the reciprocal of? Cosine. And what's the cosine? The leg adjacent over the hypotenuse, x over r. So then what would the secant be? R over x. So do you see where I got the r over x here? Okay. Now, do a little algebra. What happens when you square y over x? You get y squared over x squared. Okay? And over here, r squared over x squared. And if you multiply the whole equation through by x squared, what happens? It'll cancel in the first case. Here, we're just going to get x squared, and here it'll cancel. Okay? And I come up with this final line of y squared plus x squared equals r squared. Look at this triangle, and what have I just told you? Y squared plus x squared equals r squared. Isn't that just the Pythagorean theorem? When you've arrived at that, you basically prove. So there's an example of an identity that we had a little time on to prove. And I wish I could take through some more. I'm just not doing well. Okay. But I am well enough to give you a quiz. Well, what did we do yesterday? We doubled the table. So guess what I'm going to ask you about? Yep. Now, I got to warn you, there's some extra columns on this. You can ignore them. I put on some extra angles on here, negatives. You can just forget them. And then I got an angle past 360. You can forget that. So in other words, just do the columns from 0 to 360. I mean, can you use your previous quiz? No. Put your old quizzes away. And put your calculators to rest also. Give you another sheet. You can go do that. Was that what we were going to do? Yeah, you're going to look at that. Maybe listen. Yeah. So the number of points on here is wrong because of those extra columns. Let me repeat. I don't want you to do the extra columns. So you don't have to do those negative angles that I have on there, and you don't have to do 1,110 degrees either, the last one. So what you should see remaining there is what we worked on yesterday. Now, did I have amnesia when it came to writing the other three functions in there? No, I did not. I purposely left those blank because a very important thing for you is, I guess it's time to turn this off. A very important thing for you is to determine which one goes where. Okay.